What's up, my beautiful people? Dilo here with Rincon de Armas. This is week 3 of FTT122, Introduction to Ballistics and Ammunition. I'll be going over 3 parts of my assignment just to give you guys a video for it. And basically, part 1 is me going over the difference between explosives and propellants, or my understanding at least from some research and reading chapters 5 and 6. So according to page 115 of SDI's Intro to Ballistics and Ammunition, the major difference between the two is the speed at which the reaction propagates, meaning how fast each kernel burns, how quickly each adjacent kernel is ignited. A reaction wave that propagates faster than the average speed of sound, which is around 1,125 feet per second, also known as supersonic, is known as a detonation. And then a reaction wave that propagates slower than the speed of sound, or aka subsonic, is known as a deflagration. According to some research I did on Dr. Van Romero's explosive properties presentation of 2012, January 26, 2012, basically the difference between explosives and propellants is functional as opposed to fundamental. Like high explosives, explosives are intended to function by detonation form from the shock initiation, right? For low explosives, the propellants are initiated by burning and then burn at a steady rate determined by the device. An example, a gun, firearm. This is considered the low explosives. It's pretty much like single molecule explosives that are categorized by, well, the required initiation strength, right? So that's my understanding of the difference between explosive and propellants. And on to part 2. Should the firearms industry find ways to move away from current propellants? If so, what could be used instead of the current propellant source? And I've repeated this again numerous times throughout my studies and my research and my videos is, don't fix what's not broken. I'm a firm believer of that. So I believe that in the civilian market, it'll be extremely difficult because we've come so far. These military contracts are then long enough that we can move them into the civilian market. It happened with the 5.56 cartridge. It's already known and proven to work. Don't touch it. Even with its small malfunctions and chances of a malfunction happening with what we have today in ammunition and propellants and ballistics, I think we're fine. I don't see something major, really major happening in the civilian market. However, I do see, based off of like different studies and watching different things on the internet, that there are a lot of scientific tests going on right now that involve hydrogen powered munitions, right? So while looking up on the internet, I actually discovered that there was a company by the name of Mac Industries that is currently developing a wide range of hydrogen powered military hardware. This is including UAVs, generators, and weapon systems. The Mac Industries won't be developing anything for the civilian market, not that I believe. It's a step towards advancing technology for our military, though. They can master, and it starts to work when they need it. Can eventually make its way. I don't see it happening anytime in the near future because we don't really have something already in the works, right? This is the only company I've actually discovered so far from doing research, doing something at this magnitude with multiple different things. And honestly, like, besides that, I did see from Ian McCullum's video coil gun from Arc Flash Labs, like the EMG-01 and EMG-02. They look like sci-fi guns. Not sure how close we are to getting that mass produced that will replace propellants, but is a possibility. That is part 2. Part 3, stay tuned. I'm actually gonna show you a couple of drawings on primers and how the differences work and the major categories that we deal with. Stay tuned. Just to explain a little bit of the cross between different primers that we are studying so far. And to start off, I'm going to go with the battery cup. According to SDI's Intro to Ballistics Ammunitions, pages 136 to 137. The battery cut primer is the standard primer type used in all shot shells and with some muzzle loaders. The battery cut primer is also known as the 209 primer. Its average body diameter is 0.209 inches, a smaller cup inside of a larger cup that features the lips around its mouth and its own flash hole. Unlike other anvil types, which are cone or pyramid shaped, the battery cut primer utilizes an anvil that is flat and features two legs that butt against the inside of the outer cup. The priming compound and foil paper cover reside inside the inner cup. The purpose of the cup in cup design is that the shot shell does not utilize a flash hole with either a floor or a flash hole. The box primer, the battery cup primer, can also easily be removed for reloading. The battery cup primer is only available in one standard size. Now we can move on to, this is a drawing I've done with the battery cup, outer cup, inner cup, priming compound. The anvil's in here. Under the anvil will be that foil paper, and then box primer, it looks like just this little part right here that's inside of the cartridge, right? Remember, boxer primers. Boxer primers are more common in the United States. They're actually the primary choice for the United States military branches, and it was invented in Europe by Edward Boxer in 1866, making its introduction to the US in 1869. There are two standard sizes, and about 6 subcategories for primers. That's small and large pistol, small and large rifle, 50 BMG, and Magnum. All right, they have one flash hole, foil paper, anvil, primer cup, and priming compound. Very similar over here in this area to the battery cup. However, it is not individualized. Then we have the Burden primer, right? Burden primer has 2 flash holes, a protective disc, anvil, primer compound is in there, and the primer cup, right? So the Burden primer is commonly used around the world, like Europe, Asia. There are 4 common sizes: small, large, pistol, and rifle, small and large for each. They have an anvil built into the case head, and you can find it in US where like surplus ammunition is found. You cannot reload a Burden primer with boxer primer because of like the die, and there's a difference in flash holes. Obviously there's 2 compared to 1, so that's the main differences in the 2 most common known primers around the world: US, Europe, Asia. Shot shell. So that's part 3, guys. Thanks for watching, and you guys have a good day.